Let's do another one. Double replacement precipitation reactions. Let's write the net ionic equation. So let's get the complete ionic equation and then write the net ionic equation and identify their precipitate. All right. Ammonium chloride. And these are solutions. Ammonium is the polyatomic ion NH4 with a 1 positive charge, and chloride is chlorine with so chloride anion with a 1 negative charge. Those charges are going to cancel each other out, and that's the formula unit. And we'll put AQ for to let everyone know that's a solution. It's in water, and that's going to be mixed with lead 2 nitrate. So lead is Pb, has a 2 positive charge. It tells you there. And nitrate is NO3. I'm going to put this in parenthesis because there's going to be 2 of them, right? 2 positive and 1 negative. Crisscross those, and that tells you there's 2 nitrates. And another AQ. And that's going to form. All right, let's switch these cations. All right, let's do ammonium first. Ammonium is all ammonium compounds are soluble. Get back to my. There we go. So ammonium is going to switch with is now going to be with nitrate, and they're both 1 positive, 1 negative charges. So we don't need parentheses. Just going to write them 1-to-1 ratio, and that's going to be soluble. All nitrates, all ammonium compounds are soluble. That's AQ. And the lead is going to end up with that lead 2 is going to end up with chlorine. All right, this chloride anion is 1 negative, and the lead is in this case 2 positive because it tells you that. And we're going to crisscross them to get PbCl2. And that's going to be our precipitate. Chlorides, halides are generally soluble, but lead is an exception. Right, oops, over there. All right, so next we need to balance this. Let's see if we can just do this by looking at it. Okay. All right, so there's 2 nitrates. There's only 1, so we need a 2 there. All right, and then because we have 2 ammoniums on the right, we'll put 2 there, and that should do it. Because there's 1 lead on both sides, and now there's 2 chlorines on both sides. So 2, 1. I'll put this just for visual. Now we need to let's write the complete ionic equation. Okay. So everywhere you see AQ, we're going to just break them up into free dissociated ions. All right, so we're going to try to write a little smaller, fit this in. So we have 2 ammoniums here, and since they're floating around in this water, they're going to be, we got to put the charges back on there. All right, that's AQ. All right, plus 2. All right, we're going to distribute. So now we have 2 chloride anions in there as well. AQ. And we're going to have just for every 2 of the ammonium and 2 of the chlorides, we're going to have 1 lead. And it's told us that was a 2 positive charge. That's also in solution. And then we have 2 nitrates. Okay, so we have 2 NO3s with the 1 negative charge. All right, I'm going to shift this over to the bottom because I'm going to run out of, I may not. Let's try this. Yes, I am. I'm going to run out of room. All right, so just imagine I'm just keep going on this side, on that line. All right, we have 2 on the product side. There's only 1 aqueous compound, so just need to separate that. So we have 2 ammonium oops, NH4. You can look at these as like moles. So 2 moles of ammonium on the products and 2 on the reactant. So they're gonna cancel out. All right, so we have 2 moles of nitrate. NO3. And then this is not soluble, so it's not going to dissociate in this solution. So we're just going to write that the way it is, PbCl2, and that's your precipitate. Now we're going to look on both sides and see which one of these appear on both sides. So these are called spectators. They're not involved in the reaction, so we're going to cross these out, these spectators, and rewrite whatever is left, and that's going to be our net ionic equation. So what do we have left? We have the 2 chloride anions, and we have 1 mole of lead cations, and they're the only ones involved in this reaction. They're going to form lead 2 chloride precipitate. All right, it should be balanced, which it is, and the charges should also be balanced, which it is as well. So there is your net ionic equation.